Good morning, my YouTube viewers. It is Crystal here, and what I wanted to do this morning is I wanted to do a code review on SVM, that support vector machine, and JAX, and we're going to do it on the Titanic dataset. And the reason why is because I found the Titanic dataset a little bit harder to work with than the toy datasets in sklearn. The toy datasets in sklearn gave a really good reading, whereas the Titanic didn't. And so it was a good idea to do these algorithms on a dataset where there's problems, where you can't get a perfect score, and then that way you can know what you're doing wrong. So what we're going to do is I have written this program in Google Colab, which is made by Google, and I've written it in JAX. But what I'm going to do here is I'm going to take out the JIT from the libraries because I couldn't get the JIT to work. You can get the JIT to work on a function, but it's a lot more difficult to get it to work on a class. And this algorithm that I have is on a class. And as a result of that, I can't get it to work. I don't know enough about JAX at the moment to get it to work because JAX is a harder library to use because it has lots of features that speed up the code and do lots of neat things. So we're not using JIT in this particular code review. So the first thing we did after we used Google Colab is you need to understand that Google Colab does not have a good undo function. So you need to be very careful not to accidentally delete or overwrite valuable code, which I have done. I've done that in the past. So you need to be careful not to do that. And so after we created our program in Google Colab, what we want to do is we want to import our libraries. So in this particular code review, with this particular piece of code, we're using pandas SPD, which is to create our data frames and process the data. We're going to import JAX, which is a neat library made by Google Brain. And it's supposed to be overtaking TensorFlow, at least for research purposes anyway. But there's a lot more code in TensorFlow than there is in JAX. There's actually not a whole lot of code in JAX on the internet, which is good for me to make this code, because if there's not a lot of code in JAX on the internet, then at least I'm putting some new code out there. So that's good. We're going to import jax.numpy as JNP. So that's the NumPy part of JAX. JAX is written very similar to the NumPy API. So if you know NumPy, then you can use JAX as well. But there are some problems because the arrays and things in JAX are immutable, which means they're harder to work with, which means you have to work around the fact that they're immutable. And so there's some things that you can do in NumPy that you can't do in JAX. So that's one thing that you need to be aware of. And as I do the code review, I'll show you how I got around these immutable arrays. We're going to import sklearn.model-selection import, from sklearn.model-selection import train test split. That's going to enable us to split our data set into training and testing sets. And import matplotlib.pyplot.splt. That's going to enable us to visualize our data. So those are the libraries. Then we're going to load the data set. Data equals pd.read.csv, and then so I found a link, a web address for the Titanic website, but this must have been European because they were using commas instead of periods. So now we've got the Titanic dataset, which is 1309 rows by 7 columns. Now since we're going to take the rows and we're going to replace them with full stops. So now in the data set, instead of rows, you've got full stops. Now we're going to impute the null values for age. So basically, if they're an adult, they're going to use the medium age, which I think is 28 or 29. And if they're a child, we're just going to use 9. So I just slapped that in the middle between 0 and 18, just to give you an idea of whether or not they were an adult or a child. We're going to impute the null values for figure. So we're going to fill in the figure with the most commonly used figure for all those missing figures. And then we're going to check for null values, and we don't have any more null values, so that's good. We don't have anything more to impute. Now we're going to convert the object columns, which are data and figure, into float. We're going to convert those into floats because the computer won't work on non-numeric values. So we have to convert that to a float. We're going to round the figure and the age, so we're just basically making the figure and the age an integer, so it'll be easier for the computer to make predictions on them. Another way you could do it is to use bins, but I didn't use bins in this occasion. We're going to convert the age. Well, what we're going to do is the age and the sex, we're going to replace the object with a number. So with the sex, if it's a female, it's a 1. If it's a male, it's a 0. If it's age, if it's adult, it's a 1. If it's child, it's a 0. And then we created dictionaries for that data. And then we replaced the values with a dictionary and in place is true. So now on the data set, you'll notice that on the age B and the sex, it's now a number instead of an object. Now what we're going to do is we're going to drop the ID because you don't need the ID. The reason for that is because Pandas automatically indexes every row of data. And now I just put this in here because I thought it was nice to visualize the data. Give you an idea of what it looks like. So you can see that the survived are green and died, and the not survived are red. So you've got more reds than greens because more people perished than survived. Now we're going to define our x and our y variables. So y is your survived column, x is everything except the survived columns, and then we print it. So you've got